Hey y'all, welcome back. This week on my bench I have a Harman Kardon HK3600 stereo receiver. This receiver comes from an era when manufacturers started, I think they were just trying to fill a void maybe, I don't know. But they started incorporating the video into their receivers, and in my opinion they all started going downhill from there. But I don't know what kind of market were they going after by doing that. I guess they weren't going after the serious audio listener. They were more after the TV watcher. But anyways, this 3600 came to me. It's supposedly in working condition, but we're going to check it out. It has these cheap plastic feet, and this one's broken off. There's 3 tangs, and all 3 of these broke off, and then the foot falls off. And then the aluminum skin, the glue let go, and those all need to be re-glued. And yeah, typically it's, you can see they're all like that. And if you look inside, the glue is pretty sparse. I'm surprised we have all the feet here. It's got a 2/3 removable bottom, which is good. So we'll have no trouble working on it. Let's look at the receiver itself. Power button, Kerchunk power button under the soft buttons. Speaker switch off, 1 plus 2, bass treble balance, and then it has a host of function and record out buttons. The top row is your function. You select which one you want to listen to. VCR or tape loop 1 and 2. These are tape monitors. Audio video, auxiliary, tuner, CD phono. And then on the bottom you can select which source you want to send out to the tape recorders. Depending on how you configure your system. Volume knob. Even this, it's got an LED in it. Felt loose though. It is kind of loose, isn't it? We'll address that. Subwoofer level. So obviously it has a subwoofer output on the back. It's got minimum, maximum, and this knob is very, very stiff to turn. It's such a tiny knob. You really have to grab it and crank on it. But I guess that's because it's proximity to the volume. They don't want you knocking that with your fingers and moving it around. Video defeat, don't know. Subsonic, loudness, mono, memory for your presets. 8 presets here, and shift AB, I guess you get 8 more, so 16 total. It has a remote sensor. It does come with a remote, but I don't have the remote. Digital display, FM, AM, seek stereo button, and tuning up and down. So it's nicely laid out. But like I said, I question why they make these. Is it for the TV watcher or is it for the music listener? So let's have a look at the back. Subwoofer output, left and right line levels. So you tie that in with a subwoofer amplifier and a subwoofer speaker. AM, FM antenna inputs. Remote input output, phono, CD, auxiliary, and AV inputs, audio, and there's a ground for your phono. 2 tape loops, either VCR or cassette or reel-to-reel or digital tape or whatever you use. Here's a little bit of a video section here. You got AV in, VCR in, VCR2 in, and then your outs, monitor out. 2 speakers to select from, 2 courtesy outlets, and then it has the switch for changing the amplifier configuration for 8 ohms or 4 ohms. And Harman Kardon started, I think it's probably one of the early receivers that started this, and they carried it through into the VXI series receivers and amplifiers. What this does is it configures the power supply for the amplifier to be either high voltage lower current or lower voltage higher current. So that's what that's about, and we'll look at that. Let's take the top off and see what's going on inside. All right. So we got a little bit of a, looks like a little bit of a issue here. Not a big one, but I don't know if that's smoke or if that's just dust from being in a dirty environment. And there's some back here too. Usually you see that on a receiver or an amplifier that sits idle for many hours, and it sets up the convection currents in the air, and then the dirt and dust in the air gets deposited on the inside of the lid. But that could also be maybe something's burned out here. I don't know. Let's have a look. Big massive heatsink in the middle, and I was looking up the specifications for this receiver before I started filming, and it says it's 90 watts a channel, and I'm kind of tending to believe that might be correct, because this is quite the design here. It's got 13,000 microfarad caps. It's got these huge chunky output transistors, a massive heatsink in the middle, more than adequate power transformer. Look at the dust on this thing. I'm going to have to take it outside and blow it off. The areas where the soot or smoke is right here, so it looks like there's a couple of voltage regulator heat sinks, and they are on probably, what is this, the audio board, or is that a video board? I don't know, but we're going to have to check that out. And if it is a lot of heat over time, I suspect capacitors will be bad on those boards too. These capacitors here. Oh, this is the video board here, and this is audio. Okay. And then the other area where there's heat was up front here, and this might be the preamplifier for the system. Volume control with a motor. A lot of dust. Okay, let's get this thing cleaned up and blow the dust out of it, and then we'll have a closer look and see if we can find any problems. Probably what I'll do first is hook it up and see how it performs. Alright, got it cleaned up, ready to try it out. You got nothing on the tuner, probably because I don't have a station. Here's the stereo. You got nothing coming out of the speakers. Nothing coming out of the speakers. Let's try AM. I don't have an antenna. Let's see if I can. Tune. Silent. No noise whatsoever coming out of the speakers. Even when I click the speakers, there's like no pops or clicks or ticks. Absolutely nothing. Okay. Well, looks like we got a good repair on our hands. There's no muting button that I can't mono. Subsonic, loudness. I don't see a mute button. FM, locked onto a stereo signal. Another stereo signal, and nothing. Memory 1. So that's our memory 1 preset. It's working. Tuned. Alright, so let's do some digging. I guess when we're totally dead, the first thing to check for is any voltage on the power supply caps. So let's just take a peek here and see what we got. 44 and 44. There's a switch, and this should jump 55. So we have voltages on the power amplifier, or at least to the power supply circuit. And when I switched it from 8 ohms, or sorry, when I switched it from 4 ohms to 8 ohms, the voltage jumped probably 11 volts each channel. Let me look and see if I can find out where the input is for this amplifier. I can see a lot of heat scorching here on around a lot of these transistors, and I bet you if I looked with my eyepiece I'd probably see some cracks as well. I don't really see them standing out right now, but you know, it's probably there. Okay, let's dig a little deeper on this one. Got a missing screw up here. Missing screw. Interesting. I don't think anybody's worked on this before. It looks like it's untouched. Nobody has replaced transistors. Well, this is weird. I hook up a tone source and it's working now. Even though it doesn't sound great. Here's the left channel. Very, very quiet. Right channel. Sounds like it's got distortion. Tuner. I have a little bit of signal coming through the tuner. That's full blast. So I don't know what is going on with this thing. We definitely have a lot of issues. That's supposed to be right, that both channels are on. That's left. Oh, it's a messed up pot. And we got both channels are going. Hook up this antenna again.
Add to cart technology. Getting things shipped in 2 to 3 business seconds. How has no one programmed these features into me?
Blood.ca. There is an immediate need for blood. We remain open throughout the pandemic to provide essential products.
So it is working, I guess. It's just very flaky. Okay, I think what I'm going to do is pull the back panel off. Some of these cards need to be, I need to pull the back panel to pull these cards out. Probably don't have to, but I think it would be better if I did. And that way I can check this board here. It's got electrolytics all over it. And this is the video card, video board. And then we got two audio boards here. And just for giggles, I tested this one capacitor and it's already open circuit. So I know I'm going to have a lot of bad caps in this receiver, or I'm assuming I'm going to have a lot of bad caps. The problem is these caps are those TK caps I've talked about before, and they don't hold up well, especially on a high hours unit like this one. So I think I'm just going to have to go through board by board and check all the caps to make sure that that's not a problem. It seems like it's got a flaky operation. Hopefully I'll find some cracked solder joints that are causing that. If not, we'll have to do more troubleshooting. But as a start, I'll start looking at caps and some of these areas that are cooked by the heat, like this area, this area, this area. There's some on the power amplifier board. There's two areas. There's circuit glue all around these large can caps, these 13,000 microfarad. So I'm gonna have to pull these caps out and clean up all that glue, and we'll start with that, and then we'll see how it's working after that. So basically what I do is I take out one board at a time. For example, the video board I already went through, no problems found. This is the tape monitor board. It's got the two tape loops, and it's got FETs on the front end here. I think the FETs are doing all the switching. Some logic chips, some 4011 CMOS, and then there's like a little controller, I guess. So basically what I do is I go through with a magnifying lens and I check every solder connection for any cracks or anything that looks questionable. If I find anything, I touch it up. And it looks like somebody might have been over this board already, because the RCA connector pins have already been soldered. And they don't look factory to me. But that's okay. That's good. And that's less work for me. And then I'll go over and I'll clean off all the old flux. But doing ESR checks on these capacitors, I'm already finding bad caps. This is a 50 volt 10 microfarad. Let's see if I can bring my meter in the frame here. $10 microfarad, and it's reading 91. That's a bad cap. This one here is 0.1 microfarad, and that's reasonably good. Here's a 0.47 microfarad. That one's good. And another 10 microfarad here. Doesn't even register. So I got a couple bad caps on this board, and I'll replace all four of these. I'll put film caps for the low values, and I'll just use electrolytics for the other ones. And then when I'm done, everything's 100% for this board. I'll toss it aside, and I'll go on to the next one. And this one will be interesting. It looks like it's been cooked by those two heat sinks. So yeah, that's what I'm doing. Okay, I believe I just found the problem to our HK3600. This is the audio input board. It's got phono, CD, I can't remember, auxiliary or something or other. And one of the transistors, the regulator transistor, is just flopping in the wind here. These, I'm assuming, are regulating the power supply for this board, because we got some highly sensitive, noise sensitive components on here, because there's a phono stage, and they're probably providing a high gain, low noise amplifier, and they want to make sure it's got low noise power supply. But I don't know, you can see this. I see the leads flopping around there, and that made our flaky connection. So let's pull this transistor off. I don't think the board is damaged at all. Okay. This is a D1260, can't read that. 1266, 1268, I don't know. But yeah, the copper's okay. Just it got pulled away from the. Oh, this one's cracked too. They're both. I guess my handling it finished it off. I noticed it was cracked before, not severely, but this one's done as well. I don't want to get those mixed up. But anyways, look how caked that or baked that board is. You see the heat coming off these devices. I'm not happy about these little heat sinks they put on it. So what I want to do, these two transistors, I believe they are insulated. Let me take one off. But obviously they're getting quite hot. Stuck on there. Holy. Yeah, so these are insulated. They have the plastic back. There's no metal here. So I don't need to have an insulated heatsink. So what I'm going to do, I was thinking of putting a heatsink, removing these two pieces of crap, and putting a heatsink in here that encompasses both transistors. And I was thinking something like this, maybe cut a strip, maybe 2 centimeters, and put it on there, and have the fins orientated with the airflow. That'll provide better cooling, but this is a little too small. I have another one here. This one might be better. This is a heatsink off a video card. It's a little too long though. I'd have to cut it probably 1/2 inch off of this. Drill a hole, and mount both transistors, and then orientate it so that the fins are up and down. That will provide excellent cooling for those two. Or I have a third option. This one here, I would have to cut it right here and just use this chunk, throw this way, and this would provide enough. This one's actually the right length, and it's got a lot of bulk to it, and I'm just gonna have to put them on the heat sink. I think that would be a lot better in the future for these transistors, because I think they're dissipating too much heat for these little aluminum bent up pieces of crap. And this would be the way to go, I think. And then once I get it all installed, I could put a dab of silicone maybe in the corner or here, just to hold it so it's not flopping around, and it'll provide some security for it, mechanical security. So I think I'll do that. I think I'll go with this one, and we'll drill some holes for the screws, put some self-tappers in there, and we'll fix this board up, because this is definitely a failure point. Now, another thing I'm noticing is we're having a trend here. Get out of the way. Let's see here. That one's okay. That one's not bad. That one's not bad. It's okay. 10 microfarad at 16. It's alright. 100 microfarad at 25. 100 microfarad at 25 should be about 0.3, and it's at 15, which is no good. Here's the other 100 microfarad on the other channel. Doesn't even register. It's open circuit. Here's these two. That one's no good. And that one's garbage. So yeah, I'm having a lot of problems with caps on these boards. These TK caps, once they get cooked, they open up. So we're going to recap this, and we're going to redo the heat sinks, and we're going to get this back 100%. This, I'm pretty sure, was the failure point of this receiver. The cracked solder joints for the power supply for the audio board. And you know what? This audio, I wonder if this is just phono here. This is all phono amp. I don't know, but I'll get cracking on that. Cut this out, cut this on in half, and then we'll start putting it together. All right, I'm back, and I'm pretty much finished with the board. I still haven't cleaned it yet, but got it recapped. I tested the caps as they came out, and they're pretty much all junk. I'm sensing a common theme here with this receiver is, it's going to have a bunch of bad caps in it. And I think I'm going to end up, in the end, pretty much recapping the whole thing. Even caps that came back with a good ESR, like 100 microfarad, for example. I had a good ESR on a 100 microfarad cap, and I tested it, and it's testing like 16 microfarads or something. It was ridiculous. So it's just a garbage caps. Okay, this is my solution. A little chunky heatsink, and it's going to fit it in. And that affords enough room. There should be enough room here for this beside the next board. And what I'll do, I'm going to secure this. I'm just going to put a blob of silicone here in this corner, maybe one here in this corner, and then maybe a blob on top, a couple of blobs, just to fix it and secure it so it doesn't flop. Because if this is flopping in the wind, well, these will crack for sure. So I'll silicone it now, and then I'll wait for the silicone to harden before I solder these up, and then this board will be done. But I think that's going to provide a little better heat sinking than these two pieces of crap. Alright, so I pulled out the main filter caps, and we're going to check them now. These are, if you can read that, 13,000 microfarads at 63 volts. There's two of them. One for the positive rail, one for the negative. So let's test this out. And we get a little over 11,000 microfarads. So it's down 2,000 microfarads. It's not terrible, but it's not great either. Let's try the other one. And this one's just a little better at 11,400. So what do I do with this? Do I replace them? I think I'm going to check for replacements. Maybe there's an opportunity here. We can maybe put in 15,000 if I can find it. I have to stay within this size footprint because there's no room in the board to increase diameter. There's room to increase the height by maybe 10 millimeters, but that's about it. So I'm going to look and see what I can do. If I can't find any capacitor that'll work in this application, I'm just going to put these back in and leave it at that. It's not terrible, but it's not good either. Pretty much every other capacitor I pulled out of the circuit board has failed. Either ESR, or the capacitance has dropped below the tolerance that the manufacturer specifies. So a lot of new caps are going in this receiver, and we'll see if I'll determine if I can replace these main filter caps too. Alright, I got it all back together. It took a lot of work, and boy, let me tell you, this thing was messed up big time. Here, I'll show you. These are all the failed caps. These aren't just marginally failing, these are failed, like completely out of tolerance, just bad caps, and they were everywhere. They were on the tuner, the input board, the tape monitor board, the power amplifier, the tone board. Everywhere in this thing had bad caps, and the majority of them were the TK caps, the green ones. These blue ones are, well, they're TK as well. That's surprising. But yeah, I don't know how many there are, 20 or 40 or something like that. But yeah, it was quite a challenge to go through and find them all and replace all of them. And I didn't even do a full recap on this thing. I could have. I probably replaced 70% of the caps, and that's not an exaggeration. That's the failed caps. So next steps, I think we're going to hook this up to actually, next steps is I want to test all the inputs, because there's no switching. It's all done electronically, and I want to make sure all the inputs are active and working, because sometimes on these electronic switching circuits they have a dead input, like a phono or an auxiliary input. But I'm going to make sure they're all working. I'm going to make sure the AM/FM tuner function is working. We know it was working before. It wasn't working great, but we're going to go through. And I want to make sure the tuner is going good, because I did replace a bunch of caps in the tuner that were failed. And then we'll hook it up and we'll do some power testing, and we'll see what this bad boy can do now, and see some frequency response tests too. Because I remember before it didn't have a good clean output. It was distorted, and I know now that why, because all of the bad caps in the power amplifier, the tone board, the input boards, they were shot. So that's the reason why I had bad audio to begin with. Even though I didn't test it, I could hear it. Okay, I'll hook this up. Oh, actually, I'll do some testing first, and then I'll hook it up. All right, so I got it powered up, feeding it a 1 kilohertz tone. An antenna here. Let's try the. Actually, first let's go over the problems. Got a number of problems. Well, 2 anyways that stand out. Heatsink's getting quite hot just from idling, so we have a fever here. Consuming on my watt meter is consuming 43 watts, and it keeps climbing, so that's far too high. It should be down around 20, 25. And I think it's just idling bias adjustment, so that's not a problem. The big problem right now is I think I have DC on my inputs, because when I switch between any of the functions here, for example, if I go to phono, CD, you hear that big thump, and that's in the left speaker only. So I got a problem on the left channel, in somewhere in the preamplifier stages, or the preamplifier stages, or the switching, the input switching. I think I have DC on the left channel, and even if I do the record function out, I still get that same thump. That shouldn't be hard to track down, because it's just I just gotta take a voltmeter and go through and check for any DC presence on the inputs and the switching chips. But if I go to, interestingly enough, if I go to VCR tape and switch between those two, and even the AV, there's no thump. So it's isolated to a part of the section of the circuit that controls the input of the phono, CD, tuner, auxiliary, and AV, and not the tape functions. Let's see, that's working normally here. And I do have a tone fed in. Where is it now? There it is, tape 2. So all the inputs work, all the functions work. We just have DC on the left channel on somewhere in the inputs. Tuner's working good.
The Mix 107 person of the day is Jake Curry, but he was only one.
I'm getting full bars, good stereo separation, everything's working good to the tuner. I haven't tried the AM yet, but there's no antenna. Let's hook an antenna up. What was that? Touch something? What happened there? Something's weird. Something's shorting out or something here. Another thing is this heatsink here is getting quite warm. It's drawing this regulating circuit here, this plus minus 15 volts, is drawing a lot of current. So I wonder if that's part of the problem. There's no hot chips anywhere. But that was interesting. I just touched the AM and did a freak out. Maybe there's something not quite right here. Hang on. Alright, let's have a look at the block diagram here for this receiver. Just see if we can pinpoint where our problem is. Tuner is everything above this we're not going to worry about. These are all the inputs, the audio inputs, phono, CD, auxiliary, tape 1 and tape 2. And this is the record selector out for tape 1, tape 2. This sits on a separate board, and I actually had this board removed at the moment, and the problem still persists. So I'm going to rule out everything in this board. It's gone. Now there's another board that I have removed. It's the phono amplifier and EQ amp for the phono stage. I also removed this board. And interestingly enough, on this board there's also plus minus 15 volt regulators on that board. So that's all out of the circuit and removed. And the problem still persists. So I think the problem lies within this chip or the tone control circuitry in this area. So like I said, what I did is I removed this board, and actually I removed the video board as well. And these 3 boards are out and the problem still persists. So it's got to be somewhere in here. Now on the phono EQ preamp board there is that plus minus 15 volt regulator, and I found a couple of blown fuse resistors on this board. So I'm going to address that and put that back in order. But I also think I have a missing voltage supply here somewhere. And let's go and look at this schematic in detail here. Okay, this is a schematic of the phono equalizer amp section. That's the board, one of the boards that I removed. And there's a connector here that goes back to the main printed circuit board, the power supply and the power amplifier. And right here we have plus VCC, minus VCC. This is actually plus 55 volts, minus 55 volts, coming directly off the filter caps. So you can see that's on the top there. And I checked these 2 resistors. They're supposed to be 10 ohm resistors, R651, R652, 2 10 ohm fuse resistors, and they're both open. So this connector supplies power for this board, and then it also feeds through back to the tuner board, the one that it's socketed into. And I'm going to check this here but I'm pretty sure I don't have any voltages here. If these are open, I shouldn't have any voltages at these two series pass voltage regulators. But this is a problem, but this isn't the problem I'm trying to track down at the moment, so keep this in mind. Alright, so here's a schematic. This is actually on the tuner board, as you can see here on the top, tuner board. And this chip, this IC802, is an LC7818. This chip is responsible for switching between the different sources. And it's a stereo chip. It has 2 channels. And I'm going to check this chip. This chip is suspect. I'm going to check this chip to make sure that we have our proper power supply voltages, which should be VEE on pin 9 should be minus 15.3, and VDD on pin 22 should be plus 14.6 volts. So I guess that's my next step, is check for these voltages, make sure these chips are powered up properly. I don't know where this power comes from, this is the thing. And let me see here, I'll have to follow some lines, but we'll have to figure out where this power is being supplied from before I go further. So let's check those voltages. Okay, we're plugged in. One thing you gotta notice, this area right here is live 120 volts, so you don't want to touch this. It's all exposed wiring. Just gotta make sure you're aware of that when you're servicing this thing. So here's a voltmeter. Here's the chip I'm looking for voltages on. So let's turn this thing on and see what we got on that chip. And we got power, yes, okay. Okay, we're looking for voltages on pin 9 VEE and pin 22 VDD. So let's count back from pin 1, 2. Stuff out of the way here. This would be pin 9 here. And we got nothing. Now directly across from it is pin 22. And we got 10 volts. Where we should have 14 point something. So I think we definitely have a power supply problem here. This is supposed to be plus 14 and a half. This one here is supposed to be negative 15. So let's have a good look at where that's supposed to come from, that power. Alright, so I just checked the schematic. Power for this chip comes from this board, from this regulator, and got 2 open fuse resistors. So I'm going to replace these fuse resistors, put it all back together, and confirm that we got voltages. And if these continue to blow, then we have another problem somewhere else that we got to address. But I do have fuse resistors here, and they're half watts, so same thing. So let's put it in and do it. Alright, so I installed 2 new fusible resistors in R651, R652. I'm going to plug this board back in, this board only, because this one supplies the rest of the tuner board with plus 15. Let's plug this in. There we go. And then I'll plug in the plus minus 55 volts. And we're going to power it on. We're going to see if we see smoke or if we're going to see a working stereo. Where's those resistors? Let's keep an eye on it here and turn it on. We still have that big thump noise. Let me see if these are warm. No, they're cool. So once again, let's check for voltages on that chip on pin 9 and pin 22. It seems like we brought back to life part of the unit. Where can I hang this? Right here, okay. pin 9. We're not even on, we're still at minus 14 volts. Plus, okay. Turn it on. Just don't want to short anything here. Minus 14. And plus 13.87. We're a little low on the plus side. Maybe we got something dragging it down. If I got a hot chip here somewhere. No? What I'm going to do is I'm going to measure the voltage drop across these two resistors, and we're going to calculate the current and see if it's reasonable or not. Okay, so we have on this one 404 millivolts. And this one we got 393 millivolts. So all seems within normal. It's not drawing excessive current. Okay, back at the schematic again. I'm still looking for the problem. One thing I noticed, that pop noise in the left channel when I switch between functions is coming from after the volume control pot, because it's not dependent on what position the volume control pot is in. So I don't think the signal that's making that pop noise is coming in from the input side of the volume control pot. I think it's something that's happening after into this preamp section here and here. There's two FETs hanging off the outputs of the preamp, and these are muting FETs. And what they do, I believe that when the signal goes high, these FETs turn on and they short the signal to ground. Let me zoom in here a little bit so I show you. Maybe we can show you on one of these. Okay, we have the FET in the middle here. We have the FET in the middle, and it's on the gate. There's a 1 meg resistor, and it goes to this, ties to this line. This line goes up, and it is the mute control line. Okay, so I have a feeling that line might be going high in between when I switch functions between, let's say, phono and tuner. It might go high for half a second just to mute any thumps or bumps that might happen as the IC switch between the different inputs. Now, these two transistors here, this Q581 and 582, they're getting plus minus 55 volts in again, and they're voltage regulators, and they reduce down to plus minus 15 volts, and then it powers up this preamplifier circuit. So I'm going to take this tone control board out, and I'm going to have a good look at it. I'm going to check all these transistors, make sure that none of them are shorted. I don't see any diodes. I did a recap on this board, and I just want to make sure I didn't put a cap in backwards, or maybe I shorted out a trace or something. So I'm going to pull the tone control board out, and I'm going to have a good look at it and see if I can find the problem here, because I don't think the problem's coming from the volume pot in the front. I think the problem is being generated here inside somehow. So let me do that. Pull out the tone control board, have a good look at it. Maybe I screwed something up. Maybe it's got a bad transistor I didn't pick up on the first time around, and we'll go from there. Alright, the other problem I'm experiencing is I replaced these two resistors, these fusible resistors. They were blown, and plus minus 55 volts. There's 110 volts across these two lines, and that's a lot of whack of power going in. And I measured the current drop, the voltage drop across these resistors, and calculated the current, and I'm drawing about 41, 42 milliamps on these lines. And if I do the math, 41 milliamps at 110 volts, what does that work out to? Let's do that quick. It's about 4.5 watts of power. These two transistors here and here, they get quite hot, and they get even when the receiver's powered down, this thing is still drawing current, and it's drawing enough current for me to burn my fingers on that huge heatsink I put in. So there's still definitely a problem here in current draw. I don't know what it is. I'm going to go through and see if I can figure it out. I don't think it's the tone board, because the tone board has its own voltage regulator, but I'm going to try and figure this out here yet. Alright, I think I'm making a little bit of progress here. Got the tone control board out, and I'm going to measure for DC voltage on the line that goes between the preamp and the power amp. There's the right and left channel. There's a shielded cable that runs between the two. I'm going to check for DC voltage on that line, and let's see what we got here. Turn this on. I test this side. It shows 0. Hang on, let's try this side. It shows 0. If I try this side, I got 340 millivolts and climbing. That's my hand touching the... So there's obviously a problem with that one side. Now, if you look at the schematic, the point I'm measuring is between two DC blocking capacitors, and it's grounded with a 47K resistor. So there should be no voltage on that line, excess voltage at all. I have a feeling I pulled some caps out of the power amp, tested them, and they were okay. I put them back in. I have a feeling one of those caps is leaky. So I'm going to go in there again and pull those two caps out, and we're going to test them again and make sure that they're 100%, and probably end up replacing them. And considering I checked this many times over, I still see the mistake. I don't know if you can see it. This cap is in backwards, and this cap is sitting on the output of the preamplifier that runs to this line. This line goes to the power amplifier. So that's where we're getting a DC voltage from, is from this backwards biased capacitor. So I'm going to pull it out and flip it around. Okay, I fixed that cap. Put it in the right way this time. Let's test one more time if we have DC on the output of the preamp. This side should be 0. And this side is 0 as well. So they're both good. Okay, reassemble, and then we'll continue testing. I got it all back together now. The one thing I don't like about this receiver, and this is a big huge pet peeve of mine, is it's plugged in, it's turned off, and we have plus minus 55 volts onto this card, and it's feeding this voltage regulator, and that is drawing current and sucking heat. So I don't understand why they do that. You know, when you shut it off, it should de-energize a lot of the circuits except for, you know, for your remote control. But on this one, they don't use a standby power supply. The power supply is fully on all the time and supplies voltages. These caps are fully charged at all times when it's plugged in, and that is a big huge fail on my part as far as I'm concerned. I'm going to let this thing sit and plugged in, and I'm going to see how hot these heatsink get. Like last time I tried, it was getting quite hot, quite to the point where I couldn't even put my finger on them. So I'm wondering what's going on here that's drawing so much current. It doesn't seem bad now, it doesn't seem to be heating up, but I'm going to let it sit for 20 minutes, half hour, and I'm going to come back and check this. Even on the preamp board, or the tone control board, there's two regulated transistors, and they're getting hot to the point where I can't even put my finger on them. And that's totally unnecessary to have that kind of heat generated for something that's already shut off. So yeah, so I'll get back to you here in a bit. Yeah, so it's been on about 15 minutes now. The power amplifier is not consuming any current. The heatsink's stone cold. This is hot enough that I put my finger. It's probably about 55 degrees Celsius, and I think it would be a lot worse if I didn't have that heatsink on there. I just don't think this is designed properly. Like, why is it consuming 25 watts from the outlet when it's plugged in and turned off? That's beyond me. I looked at the schematic. There's no provision for shutting down any of the systems when it's shut off. It just goes into a kind of like a mute. It mutes itself. That's why you're not getting anything out of the power amplifier. But yeah, this is a poor design. This is an early receiver using a remote, and it's probably, you know, because it's got the motor on the volume control. It's got a relay at the back. When I turn the power button on, the relay clicks. But the only thing that relay does is it switches on the courtesy outlet for 120 volts and does nothing else. I don't see any other circuits in here that puts it to sleep. It's just something that's always alive, and I guess when it goes to sleep the displays go off and you don't have any lights, but when you turn it on it's all there. But so I'm going to measure current through those two 10 ohm fusible resistors. I was measuring about 42 milliamps, and if I do the math for 42 milliamps at 110 volts, let's say 0.042 times 110, we're drawing about 4.5 watts through this circuit here just to keep this heatsink warm, and there's really no need for it. But I'm just going to let it sit for a while, and I'm just going to check its stability, and then we're going to hook it up and we'll do some power tests too. I want to see what this thing is capable of, test the power amplifier, and then we'll wrap it up. Alright, so I got it powered up. I'm just doing DC bias adjustments, and the spec is for 40 millivolts plus minus 2 millivolts. And there's two test probes on each channel. You hook your voltmeter up to it and you measure. When I first turned it on, it was around 15 or so millivolts, but now it's up to 41 and climbing still. As this heatsink heats up, I expect that number will go higher and higher. So I'll just let this warm up and stabilize, and then I'll get in there and do some adjustments. It looks like I'm going to be turning it down already. And from what I felt before, maybe this channel here is maybe a little bit more than this channel. You can feel the heat on this side. So we'll get it tuned in. And yeah, it's already over 42 and it's still climbing. So once that stabilizes, I'll turn it down, and then we'll do the other channel and turn that one down probably as well. See what it says. I just found out this speaker switch is quite flaky. I got it on speaker 2, barely coming through, and it's loose, like there's maybe a bad connection in there, or dirty. I'll take that apart next, I guess. So I was going to do a power test on but it looks like we got a bad connection there, so we'll do something with that. Now, I can't see anything obviously wrong with it. It might, there's no crack joints. I just might remove the switch and disassemble it and clean it, because it's got a lot of oxides on the pins. I can see it's just black. So I think I'm just going to do a cleaning and reassemble and put it back together and hope for the best for that. So I open the switch up and you can see just how black the contacts are with oxidation. And this piece here is not as bad. These is actually copper beryllium fingers, but this one here would be a silver plate. So let's see if we can get that clean. Just going to use some general contact cleaner on this and a Q-tip, and just see if any of this comes. See, it's coming back a little bit. So what I'll do is I'll keep cleaning that a few more times until I can get no more black off there, and then I'll give it a little touch of deoxide on the contacts on these fingers. Reassemble, put it all back together, and it should be good, I hope. Let me see here, we got this, snaps together. Okay. Now I'll do some more cleaning. Okay, we're all wired in to do a power test on the amp, and check and see how this is doing. I got it all dialed in. Let's try turning this thing up. Feeding a 1000 hertz tone, 8 ohm dummy load. Speaker switch is set for 8 ohms, so we should get the higher voltage output. Keep turning this up until we get to clipping. Right about there, I guess. It's hard to see in this little. Yeah, it's flat topping there. Turn it down a bit. Right there, I think. And we got 28.2 volts RMS on the output. I'll let this cook for a while. See what this amplifier can do. On the watt meter, let's see if I can read this. It's right around 260 watts, and that's both channels driven, maybe to a little bit too high. Turn it down a bit. The now that I did readjustment on the idle current for the amplifiers, the power consumption dropped from about 45 watts idle down to about 36 or so. So it's a little better. Still not happy about the way these circuits are configured, and they're powered up 24 hours. That's definitely not good. But we'll let this go for a while and heat up. It's starting to heat up now. And we'll give it a bit of a test drive. Just to notice that when I turn it up past clipping, we're not seeing the weird flutter in the power supply rails. So those caps are working, they're nice and stable. They're supplying enough of a reserve for the amplifier, so we're not getting that flutter at 60 hertz or 120 hertz flutter. But I'll just keep this right at the edge of clipping. And we're going to let this warm up. Quite a bit of heat off my heatsink, but this is still not hot yet. Okay, it's been on full power for about 7 minutes now. I'm not going to go any farther. My heatsink, my load is getting quite hot, and I think I've hit the capacity of that one. But it seems like it's running fine. let's finish the assembly and put it all back together. And actually, you know what? First, let's try some frequency response. Not that it's going to show me anything, but I just want to go through the motions here. So let's maybe do this around. What do we got here? Let's not do it full power. Let's do a little bit less. So let's go for subsonic frequencies. We've got 10 hertz. And turn this up to clipping. Right there. Subsonic filter. Cuts it by about half, I'd say. Maybe not quite half. Drops it maybe 30–40%. Loudness. Puts it into clipping. Okay, let's try high frequency. Amp's getting quite noisy. $20 kilohertz. And we're pretty flat across the range. It hasn't dropped at all at 20 kilohertz. At clipping, we're getting 26.4 volts RMS. Let's go a little higher. Really staying flat. You believe we're at 100 kilohertz. Still got a clean signal. And we got smoke. Yes. We got smoke. I think I was just torturing the Zabel networks on the outputs. That's what I was doing there. 100 kilohertz. The amplifier is fine, it just got a little hot.
This year at Walmart Pharmacy, where we have put extra safety measures in place, subject to availability. Walmart Pharmacy, partnered with Apotex.
What's that, Bessie? You want to say something?
Well, it's working, and it's quite a bit of improvement from what it was before. Believe it or not, 49 failed capacitors in this unit, and that's an argument right there for a full recap, because I didn't replace all the capacitors. I probably replaced 70% of them, or maybe 80% of them, and yeah, they were failed, completely shot. 2 fuse resistors. But I think that was my screw up, to be honest. I don't remember shorting out that power supply and causing those 2 fuse resistors to go, but who knows. And then I got rid of these cheesy little aluminum heat sinks and put in a decent one for the regulator back there, so it stays a little bit cooler. It still gets hot, but not as near as hot as it got before. My thoughts on this receiver: I think it's a big fail for Harman Kardon. They didn't take into consideration the the power consumption of this thing. Sitting turned off at idle, it's 20-25 watts. That's unacceptable. That's too much. It should be down around 3 to 4 watts. If it had a secondary power supply for the remote circuits, it shouldn't be consuming that much wattage just plugged in and doing nothing. So I think that's a big fail. If you got one of these, or want to get one of these, or planning on getting it, get yourself a power bar with a switch on it, and when you're not using it, just shut off the power bar and save yourself that how many kilowatts a year for having it plugged in. Yeah, like I said, if faced with the choice of buying one of these or something else, I would go with something else. It is a nice amplifier. We saw the power output it delivers. It's got a kick to it. No issues with the AM/FM tuner. Everything works 100%, and I didn't touch any alignment, so everything's good that way. It's got some good input features. Phono. It still has a phono stage. It's got 2 auxiliaries here and 2 tape loops, so it's capable. But like I would say, I would pass. I would not seek one of these out just for that power screw up on their part. So that pretty much closes this one out. Now that I said all that, I'd probably have a hard time selling it. But yeah, I've got no use for it. I'm gonna get rid of this. Maybe give it to somebody. Who knows? And I'll make sure they're aware of its limitations. So yeah, thanks again for watching. Stay tuned. We got lots more Harman Kardon stuff coming up, and lots of other stuff too. I got some vintage radios. I got a whole whack of stuff here. So stay tuned, and hope to see you again in the next future videos. All right, thanks for watching.